Hi all, welcome to Mathematics with Mr. Charles. Today we are continuing to look at algebra and we will be differentiating among algebraic terms, expressions, equations, and also inequations. Okay, so what is the difference among all these terminologies? So on the right of the screen here I've written some algebraic entities. So we have 2x, 3y, 4m squared, negative half x. All those are what we call algebraic terms. Okay, so all these algebraic entities I'm circling here, these are algebraic terms. Okay, x is also x here is also an algebraic term. Okay, this 2x here is another algebraic term. M is another algebraic term. Okay, the n is another algebraic term. Okay, the 3y here is another one. Okay, so algebraic terms stand alone. Okay, stand alone. We have another one here, okay, 10n 2e cubed. Okay, all these are terms. Okay, 9 1, all these are algebraic terms, and they are called algebraic terms because they are either separated from other terms by an addition or a subtraction sign. So in this case, these two terms here are separated by an addition sign. Okay, they are separated by an addition sign, and these two here are separated by a subtraction sign. This subtraction sign here separate these two terms, or they may stand alone. Okay, as in the case of here, this 2x here is an algebraic term, this one here is an algebraic term. Okay, and they are not separated by an addition, subtraction, or division sign, but they are separated by an inequality sign. Okay, and on either side of the inequality sign they stand alone. Okay, because in this case here, let me use a different color ink. This side here and this side here are separated by an inequality sign. However, the 5 is an algebraic term, but the negative 6x minus 4 is not an algebraic term. This is what we call an algebraic expression. Okay, because it's a combination of more than one algebraic terms. Okay, so when you have more than one algebraic terms combining together, you get an expression. Okay, good, great. All right, so let me write the definition for an algebraic term to the left. Okay, so, and I'll write that in a particular color, algebraic, right? Or some person say algebraic. Okay, term. Okay, terms. Okay, are usually, not usually, but are separated an addition or subtraction sign, and sometimes a division sign. Okay, sometimes they stand alone. Okay, sometimes they stand alone on one side of an equation or in equation. Okay, and we will come to what an equation is and what an inequation is in a while. Okay, so in this case here, this algebraic term, okay, let me circle it properly. This algebraic term here, the x, okay, the x, this algebraic term, and this term here, okay, they are separated by an addition sign. Okay, so the x and the 3 are separated by an addition sign. Good. Each of them is an algebraic term. Okay, same as the m and the n. Okay, they are algebraic terms. The 2x and the 3y are also algebraic terms. Negative y squared, positive 3x, all these are algebraic terms. Okay, they are separated by an addition or subtraction sign or division sign. Okay, sometimes the algebraic terms stand alone, okay, as in this case, this 2x stands alone, this here stands alone, okay, this 3y stands alone, same as this, same as that. The 2x here stands alone, okay, but it stands alone on one side of an inequation, okay. Here the 3y stands alone on the right of the equation. This term here stands alone on the left of the equation, okay. This here is not an algebraic term, okay, it's an expression because it's a combination of two algebraic terms, okay. The 5, however, is a term for itself. Good. So an algebraic term, let me just take off all this. Okay, so an algebraic term has two parts. Okay, there are two parts to any algebraic term. So let's say you have 2x. Okay, 2x. 2x has two parts. This is an algebraic term and it has two parts. You have what you call the variable. Okay, you have the variable. Okay, the variable, variable. This is a variable part of the algebraic term. Okay, it's usually a letter, okay, in the English alphabet or in the Greek alphabet. So sometimes you might see some variables like alpha, right, which is a Greek letter for A, beta, okay, that's another variable. Okay, in the Greek alphabet it's the letter for B. Okay, you have also theta. Okay, you have delta. Okay, you also have gamma. Right, gamma. You have lambda. Okay, all these are letters of the Greek alphabet that are used to represent, okay, or to show that you have a variable. Okay, and aside from the variable, you also have this here, the constant. Okay, so you have the variable and the constant. Okay, the variable and the constant, and the names are self-explanatory. They are self-explanatory, meaning that the variable can take on any value. Okay, so a variable can be any number. It could be 1, 2, 3, 4, 5, whatever. It could be a decimal, a fraction, whatever you want the variable to be, that is what it would be. Okay, so if you want x to be 3.5, then x is 3.5. Okay, there are cases where you are told what the variable is, and we would come to that when you're looking at substitution. So for example, you are told that x equals 6 or x equals a half, right, or y equals 10, and so forth. Okay, so the variable can take on the value of any number. However, the constant do not change. Now when you have a constant in front of a variable or to the left of a variable, that constant is called a coefficient. Okay, so anytime you have a constant to the left of a variable, it's called a coefficient. Okay, coefficient. F-F-I-C-I-E-N-T. Okay, it's called a coefficient. Okay, and the coefficient, okay, is like an adjective that further defines the variable. So it's not just one x we have here, but we have two x's. Okay, great. So let me just delete all that. Now, this was an explanation of algebraic terms. We also have expressions, okay, algebraic expressions, and let me write that here. Okay, expressions. Okay, and expressions are basically a combination of two or more algebraic terms. A combination of two or more algebraic terms. Okay, there is no equal or inequality sign in an expression. Okay, in an expression. Okay, so for example, all these here, okay, all these here are expressions. Okay, the x plus 3, the m plus n, negative y squared divided by 3x, 2x minus 3y, all these are expressions. Good. Also here on this side of this algebraic entity here, mn minus 1, that's an expression, right? Only that part. Okay, we're leaving out the equal 10n, but the left side of the equal sign is an expression. Okay, here also the left side of the equal sign is an expression. Okay, here we have an expression negative 6. Okay, negative 6x minus 4, that is an expression. Okay, negative 6x minus 4 is an expression, right? So expressions are combinations of more than one algebraic terms. Okay, and they have no equal sign or no inequality sign, okay, in them. Good. So that was expressions. Now we have inequations. Let's do equations first. Okay, equations. We use the same color. Equations. Okay. So in equations, for equations, you have one expression. One expression is equal to, right, another expression or term. Okay, and vice versa. So for an equation, you have one expression equal to another expression or a term, or you could have one term equals to another expression. Okay, you must have an expression, okay, on one side of the equation. Well, you don't must, because for example, let me show you. Let's say you have 3 is equal to 5x. That's an equation. Okay, 3x squared equals 5x. That's an equation. Okay, 3y minus 2 equals 4x. That's another equation, right? That's another equation. So equations must have an equal sign. Okay, they must have an equal sign. Inequations, on the other hand, they have an inequality sign between algebraic terms slash expression. So it's either a greater than sign, a less than sign, greater than or equal to, less than or equal to. So all these here in blue, these are what you call equations.